Alright, I'm doing Unit 1, Topic 4, number 37 through 41. Number 37. If two parallel lines are cut by a transversal, which angle pairs are congruent and which angle pairs are supplementary? Remember, supplementary means that it adds up to 180. So instead of drawing parallel lines and a transversal, I am just going to use this half. Alright, so I'm going to highlight some angle pairs that are congruent. So for example, 1 and 4 are congruent because those are vertical angles. 1 and 5 are congruent because those are corresponding angles. I call caps. And 1 and 8 are congruent. Alternate exterior angle theorem. And 4 and 5 are congruent because of alternate interior angle. So as you can see, the congruent ones are the alternate sides. So 5 and 4, 1 and 8, 2 and 7, 3 and 6. Those are also congruent. Right? So, which angle pairs are supplementary? So these purple are all congruent. These red ones are also all congruent. And any mixture of purple and red would add up to 180. So for example, 1 and 2, mixture of purple and red, those are a linear pair. So linear pair postulate. Also, 2 and 5, red and purple, those are same side interior angle. Same side interior angle theorem. And then you have same side exterior angles like 3 and 6, which are both red. Same side exterior angle. Those all add up to 180. So as you can see, if they're on alternate sides, they're congruent. And if they're on the same side, they're supplementary for the most part. Alright. Number 38 is a pretty difficult problem, I think. So let's go for it. We know that M is parallel to N. So you highlight those, right? Because we know that information. We also know 1 goes with 16. And they want you to prove that P and Q are parallel. So I'm going to put question marks on that because we just don't know it yet. So starting off the proof with the givens. M is parallel to N. Angle 1 is congruent to angle 16. That's given. Alright, the way I like to think about these problems is 4 worlds. So this is world 1, this is world 2, this is world 3, and this is world 4. And right now we have information on world 1 and world 3. And I kind of want to bring 2 or 4 into the picture. So when I'm deciding between world 2 and world 4, what I'm really looking for is my parallel line. So these are my parallel lines that I need. So if I want to bring this world in, that's fine. I'm going to bring 1 with 9, okay? Now I'm not going to bring 12 with 16 because you just want to concentrate on half of it at first. So that looks normal to me. Parallel lines, transversal. So I'm going to bring in 1 with 9, like that. So I know angle 1 is congruent to angle 9 because of caps. I mean, there are a lot of ways you can do this, but I like to ignore half of it and try to bring something else in. Alright, so now I'm really happy because I have world 1, something in world 3, and something in world 4, which is now my 9. Alright, so if 1 is 16 but 1 is also 9, you know that 16 and 9 have to be the same through transitive property. Alright, you could think of it as 16 is 1 and 1 is 9, so 16 is 9. When two things equal the same thing, they equal each other, that's transitive property. Alright, so I know 1 is 16, I know 1 is 9, I know 9 is 16, one big happy family. So how can I prove, now that I know that 9 is 16, okay, Now that I know that 9 is 16, I worked really hard for that. I know these two lines are parallel. How can I prove that these two lines are parallel? Well, what kind of angles are 9 and 16? They're on alternate sides, and they're on the exterior. So you know that line P is parallel to line Q because those are alternate exterior angle theorem. Okay, alternate exterior angle theorem. Whenever you're trying to prove lines are parallel, though, you have to use the converse. So the answer is converse of alternate exterior. Again, this is a really hard problem. There's many, many, many ways of doing it. This is just all right. Number 39, given. I love given. Make sure you draw them. So angle A, angle D. Drew it. Check. One given. All right, next given, AB, that's a side. Side AB, side DE. Given. All right. I'm trying to prove that CE and CB are the same. So CE is here. I'm going to put a question mark. And CB is here. I'm going to put a question mark. So I know my goal. All right. I'm looking at these two triangles and I'm asking myself if they're identical twins. Are they congruent? Well, I do know that these angles are congruent because of vertical angle. Now, I'm a little bit lazy, so I'm just going to call them angle 1 and angle 2. Angle 1 is congruent to angle 2 because of vertical angle theorem. All right. And finally, I know these two triangles are the same. So triangle BAC is congruent to triangle B is partners with E, A is with E, and C is with C by, and then I look. This is a side, this is an angle, and this is an angle, and this side is not loved by this angle. So it's side, angle, angle. Or, if you went the other way, angle, angle, side. But you cannot say angle, side, angle. All right, next, I want to bring in my question. So why is CE the same as CB? Well, because the triangles are congruent, everything about them is the same. They have 3 sides that are the same and 3 angles which are the same because of C, T, C, T, C. All right, so to me this is a CP proof. You show that the triangles are congruent and then you use CP. All right, 2 more problems. Number 40. Number 40 is exactly like number 39, except it has more vocabulary. So the first vocab word I see is midpoint. Uh-oh, just a second.